So let me continue now with part one, which is the review of the front-end architecture I chose, the application programming interface I developed, how I did authentication, and my general app design through some diagrams. And this again is for the banking application. I had the entire application running in the cloud in a DigitalOcean droplet, which is their fancy word for a virtual machine. So that's up in a virtual machine, and in that virtual machine, I have 3 Docker containers. And each Docker container is one of the 3 tiers of my 3-tier MERN application. I have I have a front-end container, a back-end container, and a database container. So the whole UI is running in the front end, the actual application code is running in the back end, and the database serving and interfacing to MongoDB is in the database container. That database container is actually an image of Mongo from Docker Hub, but I'll show you in a minute, I actually built it as a third container my own way so I could control the name of the image, the volume, and the container itself. This is what that all looks like in Docker Desktop. You can see I've got my template application, app name, and its 3 containers, and then I have the Bad Bank project named Bad Bank and its 3 containers. I found out that if you do consistent naming, Hail Caesar, all of this works out really nicely in Docker Desktop. It automatically stacks the containers for you and keeps everything really well organized in that view. These are the images that are right behind the containers. You can see there's 3 images for the app name template, and there's 3 images for the Bad Bank application itself. And then they have matching volumes behind those. And through Docker Compose, I found I could take control of the names of all of these things. The names that get auto-generated are huge strings of numbers, which are a nightmare to try and keep track of. It's so much easier to look at it when the names are the ones you chose, and they're very consistent. You'll notice here in the volumes, there's a 4th volume for each app that ends with MongoDB. That is the external volume that actually holds the persistent data. And I'll talk about that more later. Again, this is all controlled by doing a very detailed Docker Compose YAML file, which builds the volumes, gives them names, and then builds the 3 Docker containers and makes references between each other and back to those named volumes and images. Inside the front end container is the UI code to make the web browser presentation of the app to the user. It is built using React.js JavaScript, and it has in it a custom API that will query a Express backend that has a data abstraction layer in it, a DAL in it. Another piece that I developed here, because I want to do this long term, is I developed a microcode client library of Java code that has my own event logging and exception handling and exception logging code in it. I built all of this with Node.js and JavaScript, and that's what's in that front end container, basically React, my own code, and Node. Inside the actual UI, I want to talk about the UI components that built it. These are all React components. The first one is basically just called app, and it is a React application that makes a single page app. A SPA is the acronym they use for that, SPA. The app application controls the definitions of the routings and then instantiates a nav bar, a navigation bar across the top of the application that routes UI commands to all the different React components. Each of the React components is in its own file, and the name closely matches what is in the UI. And there is a common component that you don't see on the screen called bank card, which is underneath each one of those UI components. This is all housed in my application in VS Code, Visual Studio Code, in a very organized manner where you can look at let me see here, this is my Capstone project. You can actually see this is the back end, here's the database, and here's the front end. And if I dive into the front end and look at the source code, you can see here's my API for talking back to the back end. And here are all the React components for account. There's the Bad Bank common application. component, card component. So everything is really well organized, and part of that was from my app template. Is where that framework came from. I just cloned it and then made it look like I wanted it to look for a bad bank. In the UI design, I made a couple changes to some of the examples we were given. The first thing I did, or one of the bigger things I did to the UI, was I added what I call a user alert or a user alert card. In many of the applications I've done in the past, I've presented something like this to the user because every app needs a way to present time-sensitive feedback to the operator in a very consistent and easily understood way. In the past, I've done things like event banners along the bottom of the screens. We use that in a lot of the factories, but every app needs something like that. And you can see a lot of websites and Microsoft and even OS is struggling with how to standardize doing that. In this application, I chose to do it as a second bootstrap card, a small one underneath the main bootstrap input card. And I did it by allowing the bank card component, the common component, to take another property, which is status. And in that status, if there is anything there, if it's not null, if it's not empty, then the bank card builds this alert for the user and sets the styling and the color based on data that's in that status that's passed. So in real time, while he's typing, I can give him a warning about bad data input, or when he is about to do an overdraft, I can have that pop up on the screen, and I'll show you that in the demo. And I can also do success. So you can see I can colorize it all based on whether it's whatever its severity is, and all of that matches my common logging utility as well. For the authentication, I use server-side password authentication and handled all that in the backend container. The front end takes the data in the create user account component and then passes it complete back to the server for the storage in the database and for retrieval later. There's a picture of my structure or my account record here on the right in green. This is Tony Stark's account. He's got $1 million. And you'll notice in the middle of it, I've created an extension to the examples given in the class where I now have a transaction history. And he opened his account by doing this initial deposit of $1 million and 1 cent. The authentication I'm doing is really bad. It's not encrypting the password on the client side before it goes to the server. So an open text copy of the password is passing between the client and the server, which could easily be hacked. The second authentication method that I put in is login with Apple ID. I did that by putting a sign in with Apple button in my login. And then when you click that, it goes right into Apple's own code on their website and allows you to put in your or log in as your Apple ID and then share whatever information you want to share from your Apple ID back into the app. That was quite challenging, more challenging than I thought it was going to be. I had to join the Apple developer program again or renew my membership that had expired. And then you have to go back into the back end of Apple in the developer system and generate app IDs. So I had to generate an app ID for my template, and I had to generate another one for my bad bank. And then you've got to generate a service ID to be used in the conversation your app does with Apple. On the front end, I had to add the Apple ID button. That was very easy. And this is the code that you import with React Apple Sign-In Auth, which is a nice package up in GitHub to do this. That uses script.js to pull the actual Apple script, JavaScript code into your application. Then when you put the button in, it's just this. The on-click event is just a call into that script to execute the Apple code that you're given. On the back end, I had to create a post listener path in the Express app to get the Apple notifications and respond back to them the way they want to be responded to with a path to your application. So that was a little bit more work than I thought it was going to be, but it was good experience because I'm going to reuse that for my company. So let me talk a minute about the application programming interface that is in the front end and talking to the back end Express server. This is all written in JavaScript, and it utilizes a single line of Axios code to actually do this. Every one of my paths through the API to an endpoint is basically 3 lines of code that define a function, set up an URL with the path to the endpoint and the parameters that are going to be passed, and then it ends with calling a single routine that handles the Axios call to go and get the server side done. You'll notice on the screen everything is documented in JSDoc, and I did that throughout the code, throughout all my code while I was developing, knowing that at the end I wanted JSDoc work, and I use something similar in C# in Visual Studio. Because at the end you get this, you get your entire application and its API auto documented for you through a JSDoc command that pulls all that into this beautiful UI. And so that's what we're looking at there. One of the reasons I didn't go beyond the self-coded API and DAL is I wanted a complete understanding of how a REST and RESTful API works right down at a byte stream level. I didn't want to jump immediately into using Apollo Client and GraphQL and Strapi, which I'm going to use for my production work for microcode because those are fantastic tools. But before I did that, I really wanted to understand what was happening right down to every byte that's going back and forth between the client and the server. And so in the interest of doing that, I I spent a lot of time again on the framework behind the application where I created my own logging, like you see here on the right, where I can colorize and I use iconographs to put very readable events into the console and into the back end. So while I'm debugging things, I can easily watch what's happening and I can log into this, basically the console as a UI, what's happening inside my application. This let me completely understand what's happening from React through its components to my API through Axios and then into the back end, which we'll talk about in part 2. But without having done that, I think I would have missed a lot of details if I had just jumped to Apollo Client and GraphQL. I now understand how those things work because I had to do it myself. It was pretty painful to do it all myself and to understand it at this level, but it's going to pay back in spades. In part 2, I will talk about the back end, how the API is handled in the Express app, the data abstraction layer, and the database. Thanks.